Welcome. Now we're going to see the what is the variation of the shape function on a one-dimensional bar element. So we know that one-dimensional bar element it has a two nodal point. So let us try to draw the one-dimensional nodal points on a simple bar element. Let us take this as a simple bar element having a nodal number 1 and nodal number 2. So we know that from the past class, so there would be two nodal points are there, each nodal point having a 1 degree of freedom. So therefore it has a 1 degree of freedom at nodal point 1, it has a 1 degree of freedom at nodal point 2. So there are the two nodal are there. So therefore in this bar element there would be two shape functions are existing. So the total number of shape functions existing for a element having a two nodals and each nodal point having a 1 degree for a bar element would be a 2. Okay, so those are called as here we can say n1 and n2. So in the last class we have defined that the shape function n1 can be defined as 1 minus zeta by 2, and n2 we have defined that it is equal to 1 plus zeta by 2. So this is a shape function formulas. So we know that at nodal point 1 we can say that zeta becomes that it is equal to minus 1, and at nodal point 2 we know that it is equal to the plus 1. So this expression is in the local coordinate system. So whenever you are going to express that in terms of the local coordinate system, the coordinates values are ranging from the minus 1 to plus 1. After all, it is a one-dimensional element, so therefore it is a function of the zeta only. So the zeta is varying from the minus 1 to plus 1. So now I need to plot the what is the variation of the n1 on a bar element. Okay, so what is the n1 variation? So let us try to take the same element having a two nodal point 1 and nodal point 2. Let us try to define the what is the value of n1 at nodal point 1 and at nodal point 2. So let us try to define that at node 1. So therefore at node 1 the zeta becomes that is equal to the minus 1. So if zeta becomes minus 1, therefore n1 can be it is equal to the 1 minus and zeta. So therefore zeta would be the minus 1 and divided by the 2. So this becomes that 1 minus into minus become that it is equal to plus, and this will become that 2 by 2. It will give that equal to 1. So now at this point of time I can say that the n1 value will be equal to 1 at nodal point 1. So this is a very important one. So the shape function value n1 become that 1 at nodal point 1. And similarly, let us try to find out the what is the value of n1 at node point 2. At node 2, the zeta becomes that it is equal to the plus 1. So therefore, n1 at node 2 can be written as 1 minus of plus 1 divided by the 2, and this will become the 0. So here the value of n1 would be equal to the 0. So at nodal point 1, it is a value become that 1. Let us say this height become that unit 1, and here at nodal point 2 it is equal to 0. So join these 2 points, so it will give that the variation of the shape function throughout a element. So this is a plot of shape function n1 throughout a bar element. Similarly, let us try to plot the what is the variation of the n2. So let us try to draw the variation of shape function n2 on one-dimensional element. Okay, so we know that the one-dimensional element, let us try to take the same element. Okay, so the same element having a two nodal point, nodal point 1 and nodal point 2. So let us try to find out the what is the n2 value at nodal point 1 and try to find out the what is the n2 value at nodal point 2. Let us try to find out at nodal point 1. at nodal point 1, the zeta becomes that minus 1. At nodal point 2, we know that zeta is equal to plus 1. So we know that the N2 formula is equal to 1 plus zeta by 2. So at node point 1, it is possible to say that the N2 value would be, so let us try that node 1. At node 1, the N2 would be equal to the 1 plus zeta becomes that minus 1 divided by 2. So plus into minus becomes that it is minus. So 1 minus 1 will become that is 0 by 0, 0 by something equal to the 0. So N2 value at nodal point 1 will become that 0. Similarly, the N2 value N2 at node 2 means that at node 2 the zeta value becomes that it is called plus 1. So therefore N2 can be written as 1 plus and zeta becomes that plus 1 and divided by the 2. So this becomes that 2 by 2 become that 1. So therefore N2 at nodal point 2, it is possible to say that it is equal to the 1. So now let us try to plot the graph. So I know that one at nodal point 2, it will become that the magnitude becomes that 1. So let us draw the straight line from the point 2 or from the nodal point 2, and this height let us represent it is equal to the magnitude 1. And at nodal point 1 it is 0. So therefore join these two with a straight line. So this is called as that is called variation of the shape function N2 for a given bar element. Thank you.